Hi everyone. In a previous update video about my shader, I briefly talked about flow maps, and since it's not a topic that gets explained very often, I thought it would be interesting to make a dedicated video about it. Some clips and explanations from that update video will be reused here since they are still relevant for this topic. So in this video, I want to explain in simple ways what flow maps are, what they can be used for, and a few ways to create them using Substance Painter and Krita. So what exactly is a flow map? A flow map is essentially a texture that stores directional information. In practice, it lets you control how an effect moves across the surface of a model. In most basic setups, the red and green channels are used to represent direction on a 2D plane. The blue channel is usually not used for the flow direction itself, although it can sometimes be repurposed as a mask or for additional controls depending on the shader setup. At first glance, flow maps can sometimes look similar to normal maps because of the colors and gradients, but they serve a very different purpose. It is important not to confuse these with normals. While normals tell the light which way the surface is facing, tangents define the flow across that surface. Think of it like a field of fur or a stream of water. The normals point straight out from the surface, while the tangents point in the direction the fur is groomed or the water is flowing. Flow maps work in a very similar way conceptually. Instead of affecting lighting, they control how textures or effects travel across the surface. So you can think of a flow map as a way to guide motion across a mesh. Before creating a flow map for your model, it is important to understand some limitations related to tangents. Preparing your model correctly early on can help avoid artifacts and quality issues later. By default, Unreal Engine uses the tangents generated from UV channel 0, so the tangent direction is closely tied to the UV layout of that channel. It is possible to use a secondary UV set to override or control tangent direction, but depending on the effect and texture resolution, artifacts may become more noticeable. For the best quality, I generally recommend using UV0 whenever possible. Another common issue appears on symmetrical meshes. Default-generated tangents can sometimes create visible seams or distorted the effect near the center of the model. To reduce these artifacts, it is usually better to export tangents directly from your modeling software instead of relying entirely on Unreal's generated tangents. Depending on the workflow, you may also need to triangulate the mesh before export, so the tangents are imported correctly into Unreal Engine. Once re-imported properly, these issues are often greatly reduced or completely removed. Mirrored or overlapping UVs can also create problems. Since tangent direction depends on UV orientation, mirrored UV islands often produce visible seams because the tangent direction flips across the symmetry line. If modifying the model is not an option and you still want to reduce these artifacts, another approach is to use a procedural tangent direction inside the shader. This ignores the mesh tangents and instead uses a flat, consistent direction across the surface. However, this also means the entire surface shares the same flow direction, which may not always produce the desired result. So overall, flow map effects generally work best on meshes with properly imported tangents, on UV0, on non-mirrored UVs, and with well-hidden seams whenever possible. So now the question is, how do we actually create this flow map? I will show two workflows that have been useful for me. First one will use Substance Painter, and the second one will use Krita, which is free and very accessible. So let's start with Substance Painter. I am currently using Substance Painter 2024, but the workflow should still be very similar in newer versions as well, at least at the time this video was recorded. Adobe has mentioned that a dedicated flow map channel is planned for the future. For now, the recommended workflow is to use the normal channel. Before starting to paint, we need to prepare a small neutral texture. This texture should be 16 by 16 pixels, with the color set to red 128, green 255, and blue 128. This corresponds to a tangent space vector pointing upward in DirectX normal map conventions and is used here because Substance Painter's flow map workflow currently relies on the normal channel. If your workflow uses OpenGL normal map conventions instead, simply invert the green channel, which gives a value of 0. I import this texture into Substance Painter, and I recommend keeping it in your library permanently, so you do not need to recreate it every time. In your material, make sure the normal channel is enabled. The other settings may depend on your project, but I usually set the normal mixing mode to replace, because I do not want to blend the flow map with the model's own normal map. In the layer stack, I usually place a fill layer using the neutral flow value as a base, which is 0.5 in the red and green channels, to ensure Substance's vector blending math behaves correctly. I keep the blue channel at 1 during painting, and simply exclude it later during export. On top of that, I add a paint layer. For the blend mode, I use Normal Map Combine. Normal Map Combine is useful here because it blends directional data more like a vector operation instead of just mixing colors. That helps preserve the painted direction more consistently when you stack strokes. Just make sure you apply that blend mode to the correct channel, which is the normal channel. Otherwise, it will not affect the right data. For the brush, you can use the basic brush. Make sure it only affects the normal channel. In the normal slot of the brush, place the texture you created earlier. Then go into the brush settings and enable follow path. This is important because it makes the brush orient itself along the direction of the stroke. Once that is set up, you can start painting. If the result feels too sharp or too rough, you can adjust the brush settings to make the results smoother. The standard brush is fine, but if you're working on hair like me, you could use the curves tool instead. This is incredibly useful because it lets you paint your actual hair strands or anisotropic patterns while automatically aligning the flow map direction at the same time. It gives you much more control, keeping your fine details perfectly clean and non-destructive compared to a standard brush. The brush settings are exactly the same. One of the nice things about Substance Painter is that you can paint directly on the 3D model. That makes it much easier to understand which direction to paint, because you are working on the surface itself, instead of guessing everything in 2D. I made a few cuts on this model to show what happens when the UV direction changes. The painted vector follows the UV orientation. Substance Painter is actually very good at blending across seams, and in most cases there will be no visible issues. However, in some situations, sharp changes in UV direction can still create visible artifacts depending on the effect. Like with most models, it is generally better to place seams in less visible areas, or in places where a seam would make sense anyway, such as along the stitching of a piece of clothing. If that is not possible, you can try to minimize the change in direction by orienting your UV shells in a similar way. For example, on these hair strands, I aligned the UVs from top to bottom, so the flow direction remains more consistent across the model. Next, when exporting your work, the settings will depend on how the flow map is used in your project. Since the flow direction is stored in the red and green channels, you can either export the texture as a normal map or separate the channels depending on your workflow. If you only need the flow direction, the blue channel is not required and can optionally be reused for something else, such as a mask. In most flow map setups, the neutral value is 0.5 in a range from 0 to 1. In other words, values around 0.5 represent no directional offset, while values above or below that midpoint create movement in different directions. Whenever possible, I recommend using a 16-bit PNG or EXR, especially if your effect relies on smooth transitions. The additional precision helps reduce visible stepping and banding. If you plan to export a 16-bit texture, make sure the normal channel is also set to 16-bit in the texture set settings, which it should be by default before you start painting. Otherwise, the extra precision will not be stored while you work. Sometimes the direction of the effect may appear reversed compared to what you painted. That can depend on how the flow map is interpreted in your project. If that happens, you can try flipping the red and green channels using a levels adjustment. Just make sure you only flip the channels you actually intend to change. And that covers the basic Substance Painter workflow. Now let's look at Krita. Krita is free and open source, and even though it is mainly a painting application, it works surprisingly well for flow maps. This workflow is focused on painting directly in UV space, which can be a disadvantage or an advantage depending on what you need. Before painting, we need to adjust the color settings for the texture and the brush. For this type of texture, it is better to treat the image as data rather than color. So I work in a linear color space to avoid unwanted gamma correction while painting. I recommend working in linear spaces for calculations, and 16-bit or higher gives better blending quality in color-managed workflows. To do that, when creating a new document, set the model to RGB alpha, choose 16-bit integer per channel for the depth, and select a linear color profile. If you already have a document open, you can access the same options by going to Image, then convert image color space. Next, let's set up the brush. I use the tangent normal brush. Open the brush settings and look for the tangent and tilt options. This brush is designed for painting normal maps, but it also works very well for flow maps since it can encode directional information directly into the texture. In the tangent encoding section, you can choose the channel orientation that matches your target workflow. Different applications may expect different normal map conventions. For example, OpenGL typically uses a positive green channel, while DirectX uses a -1. For flow maps, the most important setting is usually direction rather than tilt. If you use a graphics tablet with tilt support, Krita can use the angle of the pen to paint normal directions. This can be useful when creating normal maps directly in Krita. However, for a flow map, tilt is usually not necessary since we are primarily interested in the direction of the stroke itself. Unless you specifically need to combine tilt and direction, I would recommend focusing on the direction setting. Once configured, you should see the brush react correctly to the direction of your strokes. If you want smoother results, you can also adjust the brush settings. In Krita, one of the advantages is that the brush strokes can feel very clean. For a simple workflow, I usually keep only the settings I really need and focus on smooth strokes rather than complex brush behavior. For a standard flow map workflow, I usually recommend enabling softness and using fade in the pen settings so the strokes feel smoother and more stable. In the brush tip settings, I also set fade to 0 and change the mask type to Gaussian. This helps soften the edges of the brush and prevents them from looking too sharp. Another setting that can be useful is the painting mode. If you set it to build up, the stroke reaches full strength more quickly. If you set it to wash, the color intensity is more influenced by pressure, which can give you a softer and more gradual stroke. For flow maps, I think starting first with build up, then using wash to do some polishing works well. Before starting to paint on the canvas, I recommend filling the texture with a neutral flow value first. Since I am working in a 16-bit document, the values range from 0 to 65,535. In my shader, the neutral flow direction is represented by the midpoint value, which is approximately 32,768. One thing to be aware of is that some color inputs in Krita may only expose an 8-bit range, limiting the values to 255. However, once the layer is created, you can access the full 16-bit range and enter the exact value needed. For my setup, I set both the red and green channels to 32,768. The blue channel is not used for the flow direction, so I leave it at 0. If you are working in an 8-bit texture instead, the equivalent neutral value would be 128 for the red and green channels. This step was not necessary in Substance Painter, because the color range is displayed from 0 to 1, and Substance automatically exports the correct value whether you save as an 8-bit or 16-bit texture. Once the base layer is done, I create a paint layer on top and paint the flow map there. If I have a UV screenshot, I place it above the stack as a guide while painting. This step is optional, but if you need a seamless texture, you can enable Wrap Around mode. With it enabled, anything you paint will automatically wrap around the canvas, making the texture seamless. Once I am satisfied, it is time to export. Go to File, then Export. I usually export as PNG or EXR. For this workflow, PNG is usually fine as long as I keep the texture in a higher bit depth and avoid converting it down to 8-bit during export. I usually keep compression low, and I do not force the image into sRGB. If needed, I can embed the color profile I used while painting, but the important part is to preserve the data as accurately as possible. After exporting, I check the image properties to make sure it is still in 16-bit. If it shows 48 bits, that means it is correct, because 16 bits per channel across RGB gives 48 bits total. And that is the basic Krita and Substance workflow. It is time to test our texture in Unreal. After importing the texture into the engine, open the texture settings. If I'm using an 8-bit texture and I only need the red and green channels, I can use normal map compression. That drops the blue channel and keeps the directional data in red and green. I also keep sRGB turned off, because this texture is data, not color. If I am using a 16-bit version, which is my case, I do not use normal map, because that compression will reduce the source precision. In that case, I use the vector displacement map compression and keep sRGB off. You may have noticed earlier that the neutral color of the textures exported from Substance Painter and Krita looked slightly different. Despite that visual difference, both produce the same result in Unreal Engine. This is mainly due to differences in how the two applications display and manage color data, rather than a difference in the actual flow map values. Once imported with the correct texture settings, Unreal interprets the underlying data correctly and both textures behave the same way. Once the texture settings are set up, I plug the texture into my shader and move the light around. You can see that the reflection follows the direction I painted in Substance Painter and Krita. I also made a quick animation test shader. Again, you can see that the motion follows the painted direction, while the neutral midpoint stays stable. Here is the distortion setup that I used in the video, if you want to try it out. And that covers the basics of flow maps. I hope this gave you a clearer idea of how they work and how to create your own. Thanks for watching.